Hello, this is IAT806 Lecture 1.4, in which we're talking about processing's basic graphics facilities. So the way that basic graphics in processing works is processing has built into it a number of significant number of graphics capabilities, computer graphics capabilities. And what we're going to talk about today is a number of basic graphics calls that you can make, or function calls. And they are point for drawing single pixel points, line for drawing line segments, triangles for, not surprisingly, drawing triangles, rect for screen-aligned rectangles, ellipse for drawing ellipses and circles. And we'll also talk today briefly about controlling the color of those things, because by default, ellipses, rectangles, triangles are drawn with a black outline and a white fill. When you're drawing in processing, because what the point, line, rectangle calls all do is they specify the geometry of the objects that you want to draw. And all the geometry must take place in a coordinate system that is specified for you to use. The way that processing's coordinate system works is the origin of the coordinate system, the 0, 0 point, is in the upper left of the drawing window. And we'll show the drawing window in a processing example shortly. And the x coordinate, the horizontal dimension, increases with positive values of x going from 0 to 100 and beyond to the right. That is to say, increasing positive values move you further and further to the right. In the default size 100 by 100 processing window, the coordinates run from 0 actually through to 99 inclusive. That's what's visible. Beyond 100, you may draw stuff there, but it's not visible because it's outside of the visible area. The y-coordinate starts also in the upper left, and increasing values, positive values of y, go downward from the upper left to the lower left. So 0 in the upper left corner and y equals 99 in the lower left visible corner. When we're talking about the ranges from 0 to 100, that is where you set, well, you don't have to set it, you get a default drawing area of 100 by 100 pixels. We'll show you later on in the term how to make that larger or perhaps smaller, but by default you get 100 by 100. So all drawing that you do occurs within this coordinate system. So now let's draw a single pixel point. The means of getting that to happen is you make a function call to the point function. And what you do with the point function is you spell it out just as you see, have an open parenthesis, and within the two parentheses here, you tell processing the x coordinate and the y coordinate, the x location and the y location of where that point is going to appear. So let's try that. We'll show an example of drawing a point at location 50, 50. So here's the processing window where I've typed that in, and we can see that just like on the slide a moment ago, we had point, and then here's the x-coordinate 50 and the y-coordinate 50. And over here on the right, you can see that there is also a little red underline, very similar to the spelling error thing that you see in text editors. And what is triggering that red underline is a syntax error that processing has detected for us. And down here in this red area, where I had said in the previous lecture where errors show up, it says missing a semicolon, and then in quotes what they mean by a semicolon, which is the semicolon character in double quotes. And what that's telling you is that there's this problem that needs to be fixed by you, the programmer, that needs to be fixed. And if you don't fix it, nothing will happen. So let's just put that semicolon in. Processing immediately detects that you've done that, and now when we press play, we see the little drawing area show up to the right. So what I've done in this video capture system is I've actually expanded the size of this drawing areas so that I can make certain things more visible. By default, when you draw a single pixel point, it's a little hard to see, so I've just zoomed it in a bit so that it's expanded. So this is nominally 100 pixels across by 100 pixels down, but on your video it appears just a little bit larger. So we can see that there's a single black dot in the middle. That's in the middle of the 100 x value, 100 y value region of the drawing area, and right there in the middle is where the point ended up. So let's go back to the slides for a bit. And again, in the slides, we see what would happen if you typed in point 5050 without the semicolon. You get an error pop up in the processing window, and what I'm saying in the slides is just a textual reminder of what I just demonstrated, is that compiler errors, errors that can be detected by the processing system, appear in the bottom pane, and they keep appearing there until you fix them. If you don't fix them, you're not able to make progress. In general, all statements of the kind like point, rectangle, line must be terminated with a semicolon. And the purpose of the semicolon is to tell the processing system that a particular command or function call like point is over and there's something new to come along in the text right after that. Let's go on to the next slide, and we can see now we'll draw several points. Point 3020, point 8520, points 8575, and point 3075. And so I'll just type these in now. And point 8575. And point 3075. And as you can see, as I'm typing, it's hard to type for me to type and talk at the same time, but as I'm typing, you can see that in the error reporting area down below, it's giving you hints about what the point call needs, and you may have spotted that as I was typing. Okay, that's it for that. Let's just stop it, the program. The little drawing area goes away, and when I press play, the drawing area shows up again. And as you can see, here's the 5050 point that I had drawn earlier, plus the 8520, that's 85 over and 20 down. The third point is down here, 8575, and the last one is at x equals 30, y equals 75. So you can see these last two are at the same distance from the top, the upper bound of the drawing area. Okay, let's go to the slides once again. And next we see the other major calls that we would typically use to draw geometries. The first one that we see here is the line call. The line call takes two sets of parameters, the x and y coordinate of the one end of the line segment and the x and y coordinate of the other end of the line segment. And what the line call does is draw a line between those two locations. Triangle takes three xy pairs, the first vertex location, the second vertex location, and the third vertex location. Rect is a little bit different. It just takes the x and y location of the upper left corner, and you can specify width and height. And ellipse does the same, something very similar rather. It takes the x and y location of the center of the ellipse and the width of the ellipse and the height of the ellipse. You can think of those as the two diameters, the major and minor diameter perhaps, if width and height are different from each other. Rect and ellipse also have associated functions that you can called rect mode and ellipse mode, and what they do is control how the rect call is interpreted. That is to say, you can set corner, which interprets the xy as the location of the corner, or you could set it to be the to be some other parameters. I don't recommend that you set these because, particularly in previous versions of processing, you couldn't query what the mode is, and that would be a source of misinterpretation if you're working in a team and one team member uses one rect mode and you use another. It could cause a lot of confusion, so I recommend that you don't use those. Okay, so let's go back to the processing window, and we will do a few more method calls. So let's do line, and we'll take, line, spell it out, and we'll take two of those values, 50, 50, 85, 20, hit a semicolon there, and that solves the little syntax problem that was there temporarily. Press play, and then we will see that the point that we had previously drawn, the first two on the list, have been overdrawn with the black line segment that you see here. The other 2 points are still there. In fact, the first 2 points is still there, but they were immediately overdrawn by that line segment. Let's now do a triangle call, and what we'll do is we'll take the last 3 points, and I'm going to type them in. And we'll see that once again appear. So here we go. So here now we see that there's the line segment we drew before, and here's the triangle. As I briefly mentioned earlier, the triangle is drawn with this black outline, and it is filled with white pixels. So anything that was previously underneath this triangle has been overdrawn by this triangle, and the reason why is because the triangle call is issued last in this sequence of operations. Let's now do a rectangle call with rect, and let's set that to be 40 as its x and y location, and the width to be 30, 20. Width and height, we'll do that. Press play once again. The draw window reappears, and then you can see that the line segment has been overdrawn by this rectangle, as has the triangle. Because we haven't changed any colors, we see that the rectangle is filled with white with a black outline. Finally, let's do an ellipse, and we'll do x and y 2020. That'll be where the center of the ellipse is, and we'll set the width of that to be 80 and the height of that also. Just like with the rectangle, we'll set the width of that to be 20. Yeah, there we go. And once again, there it is, the drawing area. So there's the line segment. The 4 points have been obliterated by the other stuff, the triangle, then the rectangle was drawn, and there's the ellipse. If the ellipse was located somewhere else, we would see it overdrawing these other things. So let's just set that to be 50. Press play again, and we can see that. There it is. The ellipse now overdraws the upper vertex of the triangle. It would overlap. Once again, I could move it around and would show overdrawing some things. So if we go back to the slides, you can see that that's the list of calls that we've introduced so far. But we haven't shown yet how to adjust the color of any of these things. So let's do that now. When you're controlling color and line, there are a number of things that you can control the color of. The first thing listed here is the background color. By default, the background is this mid-level gray. And what you can do is to make a call to background, which clears the screen to the color that you specify. That is to say, not only does it set what the color is, it also clears the screen to make the entire screen at that point to be that color. So what I'm going to do is issue the background call. And what it uses for parameters is red, green, and blue values, and those values are in the range 0 through 255. And where that 0 to 255 comes from is you need positive values, and the minimum is 0, as you might expect, and the maximum is, because we're using 8-bit color, 2 to the 8 is 256. So the values you can use in 8 bits is 0 through 2 to the 8th minus 1, or 255 instead of 256. So if I go back to the processing window, you can see that I had typed in the background color here. And now what I'm going to do is set the stroke, which we had seen a moment ago, to be something interesting. So let's set that to be red. And so let's set that to be a very bold kind of red. I don't generally recommend using extreme colors like this because they can be a little bit hard on the eyes because the colors are extreme, but we're just going to do that anyway just to make a point. Okay, so here it is, and what you can see is I issued the stroke call here before the line, triangle, rectangle, and ellipse, and therefore everything that was drawn used that stroke color of this very bold red. Okay, so what I'm going to do now is I'm going to go back over here cut it out of that location. I put it down here and press play one more time, and we can see that this time, now that we've got this working, we can see that the line segment is black. Just, you can see part of it between the ellipse and the rectangle, and the triangle has been drawn with a black outline and a white fill, and the rectangle and the ellipse were drawn with red outlines. Now let's set the fill color to be something also very bold, and set that to be green. I think that's correct. There we go. And so now we will end up with the triangle with a white fill and black outline as before. And because we set the stroke color to be red, we get the outline of the rectangle to be red, but the fill is still white as before, as previously. And now the ellipse is filled with green because the fill call was changed the fill color just before we issued the ellipse call. We can also set stroke weight, and its job essentially is to set the thickness of the strokes, that is to say the outlines that you're drawing of things. So let's set that to be 4 and press play one more time, and we can see now that the ellipse has a big thick outline drawn around the perimeter of the ellipse. Because we set stroke weight before the ellipse call, but after the rectangle call, the stroke weight of the rectangle is 1, is the default value. Okay, let's go back to the slides now. Okay, so that pretty much does it for a brief review of the computer graphics capabilities of processing. This is just basically a brief review of the kinds of geometry that you can use in processing.